Practice problem. This problem gives a second product cost. So y equals
Okay.
18. Then 90%. B equals 0.9.
Oh, I did that all along. Oh.
Question A asks 20th single unit. So y 20th at 90% equals k times unit factor 20th at 90%. If we use logarithmic learning curve k times 20 log 0.9 divided by log 2. From the table, the first table, %, and 20.
6342.
This one, 0.6342.
Yeah.
We need a K, right? Before we get the
Oh, see, I did
K
that.
is not given. So this one K y second times 2 B, right? So K times B equals y second. We need K, so K equals y second divided by 2, divided by B. Y second is 18, B is 0.9, 18 divided by 0.9, 18 divided by 0.9 equals 20. So K is 20.
0.9 divided by 2 divided by, yeah, that's right. Mm-hmm. Okay, it is right there.
So K is 20. So y 20 is 90% equals K times unit factor 20 at 90%, $20 times 0.6342 from the table equals 12.68. And what is the cost of producing the 64s? Y 64's 90% equals unit factor 64. But we can find the 64's unit factor. So 64 divided by 2 is 32.
Mm-hmm. Can't find.
Still we cannot find 16.
Yeah.
So reverse. 64 cannot find 32, cannot find 16. This is like a doubled, right?
Mm-hmm.
And times b times b.
Mm-hmm.
So unit factor 64 cannot find 32, 16, find the 16 times b and times b. So 0.6561, that is from the table. %, 16ths, 90% is 0.6561. .6561 times 0.9 squared, because we went up twice, right? Divided by 2, divided by 2, right? So times b, 0.9 squared. Next question.
Can you go back one quick second? I'm sorry. I just need one. Okay.
What is the total cumulative cost of producing 100 units of the product from 101 to 200? (101) 200 cumulative area equals bigger one 200 minus smaller one 101 minus 1 equals 100, right? So equals y 101 to 200 equals k times cumulative factor equal 1 minus cumulative factor smaller 1 minus 1 is 100, right? So find cumulative factor only 60. Way down. And you can get 200 is 105. 105 and 100 is 58.14. 101 to 200, that is cumulative factor 200 minus cumulative factor 100, not 101, minus 1. That is 105 minus 58.14 equals 46.86. So 20 times 46.86 equals 937.2. If you understand the concept, unifactor, if you cannot find half of that one, then times b, the arithmetic learning curve concept, and then the area, middle, bigger one minus, smaller one minus 1. Cumulative factor, find, and then times like this. It's not very hard. Okay. Previous quiz number 5. Quiz number 5. Second question will be from this chapter. Looks like this. Okay. So find the file and so there is answer file like this. So you can practice yourself and then compare answer like this. Okay. Last chapter, today's last chapter. Decision tree. Usually other instructors don't cover this one.
Yeah, that's right. They don't look that long. How long the problem is.
This chapter is not long.
It's the same. I just gave us one.
Oh, we can. Oh, oops.
Usually other instructors don't cover this part, but
Yeah.
I cover.
Thank you.
Because this one is undergraduate course, so I like to teach as many as. Anyway, this chapter is not included quiz or test. Just to let you know. Okay? Because this one is very easy.
Easy, probably. What I need.
Yeah.
Right, right.
Okay, operations management, management science, operations research, some courses like that. We call that something like decision science, decision method. when we have multiple options or alternatives, then we find which one is the best one. Do you remember what was that? Anyway, many things, then find which one is the best. Decision method. Decision tree, this one is also decision method. There are multiple options. Then which one is the best? If we have multiple options, certain store forecast future demand and the future economic condition. Then there are 3 options. First option, move store to new location because this store forecast future demand increase. Then future economic condition is strong, 55% chance. Then revenue will be $195,000 next 5 years. To move to new location, cost is $210,000. It says value, it's like a profit. $195,000 times 5 years, revenue minus cost equals value. If economic condition is not strong, weak, 1 minus 0.55 is 0.45, 45% chance. Then, because the economic condition is not strong, revenue will be less than strong when it's strong. $115,000 next 5 years, cost is the same. So 115,000 times 5 years, revenue minus cost equals $365,000 value. Next option, just expand existing store. Strong some revenue 5 years, cost is less than new location, then value is $863,000. Weak condition, less revenue next 5 years, but the cost is the same, then value is $413,000. And last option, if economic condition is strong, even strong, do nothing. First year, do nothing, but next year, second year, wow, demand increase, so expand. Then cost is $87,000. Anyway, first year, do nothing, $170,000 first year, next 4 years, $190,000, and value is 843. Even strong, do nothing, remain $170,000 next 5 years, no cost, so $850,000 value. Weak condition, still do nothing, less revenue 5 years, no cost, and value like this.
So it's best to do nothing.
Looks like stem and leaf, something looks like a tree, right? Branch and so we call this decision tree. There are 3 options. Then each option has 2 condition, right? Strong and weak, strong and weak, strong and weak. When we draw decision tree, we use square and node or circle. That means circle means expected value point. Expected value point because it associates with percentage probability. And then square here and here, decision point. Decision point. We already know the value. So compare and then decide. First option, move to new location. The value is $765,000 with a 55% chance. Weak gross, $365,000 with 45% chance. So expected value points circle, that is $765,000 times chance is 0.55 plus $365,000 times 0.45 equals $585,000 expected value. And next option, expand existing location. Strong growth, $863,000 gives a 55% chance. So it will be $863,000 times 0.55 plus 45 chance of $413,000. $413,000 times plus 0.45 equals 660,500. Next option, when it's strong, there are two options, right? First year, do nothing, but second year, expand. Value is $843,000. Do nothing value is $850,000. We already know there are two options. Value. Compare. This one is better. Higher, the better, right? So take this one, cross out. Using this value, find expected value. $850,000 times 0.55 plus $525,000 times 0.45 equals $703,750 expected value. After we get expected value for each option, 2 by 2, compare. This one and this one, 585, 660. Winner, right? Cross out. Compare this one and this one, $660,000, 500, 3,750. Compare this one higher, winner. Cross out. Finally, this option is the best one. This is decision tree.
I like it. Do nothing.
Okay, that's all for quantitative module A. This one is not in quiz. Just to let you know, this is decision tree. practice problem is attached. If you are interested in, try. Answer is on blackboard. So that's all for today's lecture.